I had the pleasure of opening up, and I've got the pleasure of bringing the last panel to you. Now, as we get started here, as you saw, there's a bit of a sequence over the course of the last 2 days, and so we're bringing it to a close, charting the path to sustainable economy. Now, here's what's written on your agenda. Almost really the sort of challenges and opportunities, and I'm highlighting the fourth R. Because essentially what we've really understood over the course of this day is we've actually answered the ministry's question that they haven't asked yet. What is the definition of recovery? Well, we've answered now, what are those other activities? Because if you've been here for both days or just today, we have covered off such a broad range of what that fourth R is all about. And it's all been recorded, and it's all going to be shared. We've talked about the different kind of feedstocks, traditional feedstocks to waste diversion, traditional feedstocks that could actually go off to a type of resource recovery opportunity. We've talked about how you can actually blend different feedstocks. You can blend different programs to make a community out there. We heard about those examples taking place in Quebec. We've heard about what's recovered and then how it's recovered and those technologies. And boy, have we ever opened the doors over these last 2 days on what we mean by different resource recovery technologies. We've also basically said our eyes have got to remain open. Why? There's too much stuff out there, and there will be. We cannot live in a dream. It would be just so ideal that in 10 years or 5 years, we'll be into a perfect circular economy. We're not. Doesn't mean we don't carry on down that path, but we've got to be realistic. And I've heard nothing but good realistic stuff over the last 2 days, and I've also heard some dreamy stuff. Let's be realistic here. But dreamy stuff is good too, because you've got to move that forward, and the marbles are all moving forward. And we've heard about where the marbles are moving forward and the different kinds of things that have come to the forefront right now in Canada, the US, over in Europe, Japan, and other locations. So our final panel here is almost stepping back to where you were for the opening exercise yesterday in the morning, looking at those challenges and opportunities. And we've got 3 quality panelists here that equally match what you've seen over the 2 days here. I am just, as a supporter of this conference, I am so impressed with the caliber that has come here to Waterloo, Ontario. And where I've got to share a little disappointment, we could not get provincial reps here. Unfortunate, but it's being filmed, and we will be banging on those doors. We were not able to get federal reps. Okay, we'll get to their doors as well. And the other interesting group that really should have been here was the media, in particular CBC. They've done some pretty cool stuff. They have helped to raise the awareness of the challenges and opportunities. So for next year, those 3 groups will be here. I can guarantee that. Our first speaker, Sandy Marshall. He graduated with a Bachelor of Applied Science and a Master's of Applied Science right here, Waterloo University. He started his professional career in 1984 with Polysar, a Canadian rubber manufacturer. Over his 30-year career in chemical and polymers, he worked on research and process, product development and market development before moving into operations and general management. Sandy finished his corporate career as President and Managing Director responsible for the Canadian operations of Lennox Canada. Sandy is currently the Executive Director of Bioindustrial Innovation Canada, a member of the Board of Governors for Lambton College, and he's the Chairman of the External Advisory Board of the Biorefinery Institute at Lakehead University. Please welcome Sandy Marshall.
Well, thank you very much for the invitation, and I really appreciate the opportunity to come here today and be part of this panel. As I listened to the panel's discussions over yesterday in particular, for a while I wondered how I fit, because I'm not a policy person. I come from the business world, and certainly the focus I've taken all along has been around business. Let me just move the air. But as we went into today, I started to really feel that I'm kind of able now to make those connections. So I want to talk a little bit about Bioindustrial Innovation Canada first, just so you have a bit of an appreciation of what we are. We're a not-for-profit organization. We are a business accelerator funded through the federal and provincial governments in Ontario. And our focus is to create jobs and economic value sustainably in Canada. We've been around for 10 years as an organization, a formal organization, but our roots go back 15 years. And we really started as an organization, as a group of individuals who were coming out of the Canadian chemical industry who were disturbed by the path that the Canadian chemical industry was taking. We were losing our plants, our sites were being downsized, plants were being built elsewhere in the world, and we really felt 15 years ago we needed to do some things to rejuvenate the chemical industry in Canada. And out of that, a group of us got together and started down this path. And what we ultimately 10 years ago, CSER was formed, a Center of Excellence for Commercialization and Research through NSERC, and this mission was, this mission was born. And so what do? We provide critical strategic investment, advice, and services to early-stage companies in the clean, green, and sustainable technology space. And our focus is commercialization. And so today my conversation will be all about economics and commercialization and how do we get to the promised land where we actually have jobs and economic value. We do this in really three ways, key ways. And I should mention here we support, as I said, support the commercialization of sustainable technologies or sustainable chemistry. Just so people understand the word sustainable chemistry, for us that means any changes or technologies that are used which are more sustainable than the current technologies that are out there. So in essence, we're trying to push the boundaries to lower GHGs, less water impacts, et cetera, et cetera. So we do this in really three ways. One of our biggest focuses is around cluster building. One of the strengths of the chemical industry historically has been the ability to leverage clusters and putting companies together. One of the greatest examples of that is in Sarnia-Lambton. There are other locations around Canada that do this. And if you think about it, go back, when you think about it with clusters, it's been this ability to work in a synergistic ecosystem where one person's co-products is another person's feedstocks and so on, that has allowed that chemical industry to flourish in Sarnia-Lambton as the first cluster. But there are other locations such as Eastern Ontario, Brockville, Maitland region. Montreal East was another great example. I would say that Montreal East has been pretty much hollowed out at this point, and there's very little of critical mass still remaining there. The second thing we focus on is we manage a venture capital fund. We've invested to date in 24 companies over the last 10 years. They're all early-stage SMEs. The difference between us and a traditional venture capital firm is that we're patient investment. We don't because we're a not-for-profit, we don't have to return a 2x, 3x, 10x back to our investors within 3 to 5 years. So we don't spend our time in ICT, we don't spend our time in medical devices, we focus on the industrial or sustainable chemistry, and a lot of that is in the space of industrial biotech. And as I said, we've invested in 24 companies over the last 10 years. I can tell you quite honestly, a number of those no longer exist, which is typical of VCs. But our mandate now is to double our value of our fund in somewhere in the 10 to 12 year range. The other part we bring is we have a strong leadership for commercialization, and that's because if you look at the board of BIC, half of our board has been in a very senior leading role in the chemical industry in Canada at some point during their careers. We have over 300 years of experience in the chemical industry sitting on our board. And this isn't a governance board. Of course, they do those activities, but they also very much focus on supporting the companies that we work with, providing mentorship, guidance, advice, as well as create a quite interesting dragon's den when we get into our and due diligence processes. So I'm going to spend most of the rest of this time talking about this slide. This slide, if there's one thing for you to remember about this 20 minutes, it's this value chain. And I'll have to say this slide was first created about 15 years ago, and it really represents the opportunities and the challenges facing us in the renewable space. The blue dots along the center here really represent the traditional petrochemical value chain. Starting with your feedstocks on the left, whether that be crude oil, natural gas, shale gas, liquids, or coal. It all starts there, and from there you basically go through series of transformations. Every transformation is adding value to those materials, and ultimately you move up through fuels and energy, which is your lowest value, up through to primary chemicals, ultimately to polymers and chemicals, and then further up into finished products and ultimately advanced manufacturing goods like automobiles, airplanes, washing machines, whatever you might want to call them. And if you look at that blue value chain, that was created 160 years ago with the discovery of oil in Oil Springs, Ontario in 1858. The first early stages of that value chain, they basically pumped that oil out of the ground in Oil Springs. They took it by horse and carriage into Petrolia, Ontario, and they extracted out the center cut of it, and they basically used it as kerosene for kerosene lamps and made whale oils and whales obsolete. From there, from those humble beginnings, which in some ways mirrors a lot of the things we're facing right now with the emerging bioeconomy or resource recovery economy, they've had 160 years to streamline, optimize this value chain to the point that when you go from fossil feedstocks to fuels, the amount of margin that's in there is incredibly small. High volume, very low margins, and it's very hard to compete in those spaces. As you move farther up this value chain, obviously the costs and values go up, but the one thing to keep in mind is that this is an extremely efficient value chain. That's the challenge as we try to plug bio-based materials into the traditional carbon value chain, which this really represents. So we've basically focused on trying to plug the green boxes into it. That's the opportunity. There is an existing value chain there. If we can take our renewable materials, our bio-based materials, and plug them into that existing value chain, we've got the potential of a market. The problem is we've got to compete in that value chain. And so if you look here, you can see some of the basic pieces there under bio-based feedstocks, obviously biomass. I modified the slide as I do for each presentation here. I put in our recovered resources because that fits in there, and so on. If you get over here to the right-hand side under processed biomass, there's also places for these materials to plug in higher up the value chain. But these are very hard places to plug in. As farther you go to the right on this value chain, the more specified the products are, the more difficult it is to hit those specifications, and the smaller the markets are. Yes, you'll get a higher price, but it's also much harder to hit the specification. So I just wanted to frame this in, and now I want to talk about five or six examples of companies that we are working with that are trying to plug their cells into this value chain, and how are they making themselves successful or not. So the first company I want to talk about is the first big fish that we landed here in Canada, or in Sarnia-Lambton. That's BioAmber. This is a company that produces succinic acid. Why succinic acid? Well, producing succinic acid through a petrochemical route is very difficult. For the chemical engineers and chemists in the room, trying to stick oxygens into hydrocarbons is not an easy thing to do. So the world market for succinic acid is 30,000 tons, and it's all produced in China from a petrochemical route. These guys had ability to produce succinic acid through a fermentation route, significantly more efficient. And why succinic versus ethanol? If you think about the feedstocks. Succinic acid has a carbon-oxygen ratio of 1 to 1. What's the carbohydrate ratio, or what's the carbon-oxygen ratio of sugars? 1. So basically, you get a high theoretical yield off of your raw materials. So you can actually take a relatively expensive raw material like corn sugars, convert it through into succinic acid, plug it into an existing value chain where the alternative is a petrochemical-based material, which is difficult and expensive to produce. The reason there is only 30,000 tons of global market was because there was always other alternatives that could do instead of succinic acid. So BioAmber came in, they developed the technology, spent $145 million US building a plant in Sarnia, Ontario, and produced succinic acid and put that out on the market and tried to push that market and grow their markets. As many know, they're facing some financial challenges at the moment, and it really comes down to the fact that they had to push into a market and get people to accept and use succinic acid where they had not used it before. Second example I have, BioAmber in their early days talked a lot about expanding and building more plants. When we started looking in Sarnia-Lambton as to could BioAmber build their second plant here, they started talking about needing 300,000 tons of sugar. There wasn't 300,000 tons of sugar sitting in the Sarnia-Lambton area. We had an ingredient plant sitting here, or sitting in London, Ontario, but that wasn't going to be sufficient. So at that point, we as a community said, we need to deal with the supply chain. And so we need to start building the capabilities to provide the raw materials, the sugars, the base materials that can go up into the primary chemicals and produce them in Sarnia. And this is when we got into the whole concept of developing cellulosic sugars. And it was through that work we engaged with Comet Biorefining, who actually now take corn stalks or agricultural residues like corn stalks and wheat straw, and through their process make high purity dextrose comparable to what you get from a wet mill. So, but how could they get? For them to get that plant built, they need a supply of raw materials. So the supply chain became a very, very important part of what they needed to do, and that's why they've partnered with the farmers, and now the biomass is coming in, and you can see that really this example is not necessarily about the technologies, it's really about the fact that all these different pieces need each other to be able to be successful. So I'm going to jump ahead to some examples away from the ag base and get into the resource piece. We've invested in a couple of companies that are doing chemical recycling of plastics. The name's been mentioned 2 or 3 times. We're an investor in Green Mantra. We also are doing some projects with Green Mantra to help them remove barriers to commercialization. And why is Green Mantra able to be successful in here? It's because they're able to take those plastics from the back end of the value chain, break them down in a very precise way to make higher value-added products like waxes. So they're not actually coming all the way back to fuels and raw materials. They're coming back to an advanced material like a polymer and able to insert that back in the value chain and do that and be able to generate enough revenue from that to be able to create a business model. So when I start looking at this here obviously looks like a linear value chain, but now you're starting to see abilities to plug things back in. Now, once it goes back into waxes and is used in other applications, that's really the end of the story for it. So we haven't totally reached a circular economy at this point. Another company that's kind of in the same place is Pyrrha Wave. These are a group out of Montreal. They take polystyrene. It's very similar to the Agilex example, except instead of using pyrolysis, they're using a microwave technology. But ultimately, they're breaking down that polystyrene through energy into raw styrene monomer, which ultimately then comes back and gets plugged into exactly the same places where Agilex is plugging their styrene. So as you can see, now when you start looking at the challenges relative to an Agilex or a Pyrrha Wave, they're now having to take these materials, break them down, and insert them earlier on in the value chain where the products have to compete at very, very low prices with the petrochemical value chain. That in there lies a challenge. But if you listen to what was said this morning by Brian, they're able to use low-quality polystyrene, and which they can get tipping fees for, and through the fact that their raw materials are very low cost, they're able to compete in this value chain. The last example I'm going to give you has nothing to do with this carbon value chain, and that's another investment we have with a company called Li-Cycle. And Li-Cycle basically has a technology where they take rechargeable batteries, lithium cobalt rechargeable batteries, grind them up, extract all of the cobalt, lithium, and metals out of it, and bring them back to the same quality as you would get if you were buying those materials directly from the miners. And so the reason that model works, and you can imagine why that that model is very interesting today because we're soon going to have ourselves a lot of batteries out there coming out of electrical cars that are going to need to be recycled. The current technologies today grind those up and then basically take the metals that are in there and sell them as a mixed bag. And they blend them in to a degree, but the fact that Li-Cycle can take them back to pure components allows them to take it right back to the front end of the value chain and plug them back in, much in the same way as we talked about the styrene monomer example. Why does that work in this case? Well, it works because cobalt currently sells at $80,000 a ton. Lithium sells for $16,000 a ton. So if you can start getting those batteries coming back and not having to pay a heck of a lot for them, you can actually put a lot of activity into that transformation, and make money. So as you can see in these examples, in there lies the opportunities, but so many of these you have to be really looking very carefully at the various elements of this. So I've got really two slides here at the end. First, I want to leave the message with you. This is a systems approach. None of this is linear. Yes, some of it's circular, but the interconnectivity of this is more like a spaghetti graph than it is anything else. And when you start working in systems, when you push on one place, it comes out somewhere else. You need to look at these things from a systems perspective, and every company that's trying to fit in these value chains has to identify where they are, simplify where they fit, and try and adapt. We talk about supply chains. This challenge has been talked about. You need access to sufficient supply of the right quality, appropriate quality, and it has to be at a cost commensurate with the competition. In there lies many, many challenges. You need to leverage existing value chains. If you decide, or a company says, I'm going to create the newest, greatest thing, and there's no market for them, it's a long haul trying to push those materials into the market. And the last one here is working within clusters or collaborative ecosystems does allow you to share services, infrastructure, reduce your costs, reduce the access need for capital, leverage common technical skills, and so on. And so these sorts of elements are really critical. And in here, there are places where you can go to link in with like-minded companies and like-minded groups to be able to take advantage of that. Key elements to consider. This is all about innovation. And innovation, there was a question put out yesterday. Innovation, is it contrary? I forget the question it had, but innovation was the specifics, but innovation versus environment or innovation. And I looked at that question and I didn't get it. I didn't get the question, quite frankly. Because innovation really occurs to overcome society's priorities at the time. So if environment is our priority, then we shouldn't be surprised that the innovation today is focusing on solving the environmental issues that we face today. If we look back in time, way back when petrochemicals and so on, and a lot of these other technologies were happening, the Industrial Revolution, no one was thinking environment. That wasn't the basis for innovation. It was a totally different mindset, so we have to be careful about comparing times. And the second point here is commercialization only occurs or only happens once viability tests are met. What that basically means, you can have the greatest innovations, but you have to pass a bunch of tests before you can actually start to commercialize that or get it through to successful commercialization. The biggest test is going to come from financiers, but it's also going to come from technology scientists and others who are going to challenge your technology, challenge your data, challenge what you're doing, challenge your supply chain or your ability to have a supply chain, challenge your ability to meet the market needs. All those pieces have to be met before you can effectively commercialize. You have to have a successful business model. Resources are limiting, and resources, everybody talks about access to capital, access to capital. Yes, that's very critical, and we try to do our part in a small way to fill part of that. But it's not just access to capital, it's access to resources, it's access to people, talent, and time. One of the biggest risks that young companies face is they don't have time. You got a burn rate. You've made so much money, you've only got so much time before you get to the finish line or before you're back out getting more money. Time is a big battle. And sustainability for a company can only be achieved once you're profitable. And you need to be looking at profitability without subsidy, because in the longer term, subsidies can be fleeting. So you need to build business models without that in mind. That does not say that there isn't a role for government in funding. They can play an important role in de-risking first-of technologies. And I will say that the governments of Canada and Ontario have been very, very supportive of a lot of the companies in the bioeconomy, putting in early-stage funding, no-interest, low-interest loans, grants from SDTC, funding of us who are putting money out there. There is help coming from the various levels of government to help these early-stage technologies, and I think it's really important in Canada, because what we see here is not the same access to capital in Canada as we see when we're dealing with companies south of the border. Policy, I don't really want to get into policy per se, because that's not my area, but I see policy as a behavior change tool. And really, policy is out there to try and get us as the citizens or the companies to change our behavior, and they do it either two ways. They punish us or they incent us. And I would say that the same policy incents some and punishes others too, so even the same policy sits on both sides of that. And it influences early adopters to lead, and I think that's really where the real opportunity lies. And a lot of the people that we're talking about, these companies I've talked about, are those early movers. So I think that's important. I just want to throw a couple examples here, just so I can tie policy back to dollars. Cap and trade, as it was put forward, or a price on carbon, is really trying to put a societal price on the price of fossil carbon. That's really all it's trying to do, so that we can level the playing field, so we can start to drive some of the other renewable pieces forward. Waste diversion legislation, what's it actually doing? It's in creating a more negatively priced raw material. Because if you're forced to divert materials out of landfill and you have nowhere to put it, what alternative do you have? Pay somebody more money to take it away, which then creates incentive to move forward. And I will say that in our current political environment, certainly across the border, we've seen it, and we don't know what exactly is going to happen in the province of Ontario. These sorts of changes require perseverance, and they will take time, and they take a lot longer time than I think we wish they did. Thank you.
Thanks very much, Sandy. Our next speaker, Lyle Clark. Lyle was a fixture on Ontario's waste diversion sector, serving on the boards of Waste Diversion Ontario and Stewardship Ontario, and ultimately taking over the reins at Stewardship Ontario until 2014, when he left to pursue opportunities in the clean tech sector. He is currently the chair of eTrax Tire Management Systems, a producer responsibility organization established to serve the compliance needs of the Ontario tire manufacturers and automakers. He's also on the board of Char Technologies, a clean tech company specializing in biocarbon development, custom equipment for industrial air and water treatment, and providing services in environmental management, site investigation and remediation, and resource efficiency. And today, Lyle's going to focus on the role of chemistry in the development of a truly circular economy. Lyle?
That's great, thanks. So thank you, everybody. Here we go. So Lyle Clarkson and Associates is all about enriching the planet, by enriching your wallet. And it recognizes that good things for the planet happen when people can make money doing it. Now, I was here partly to sell you on the idea of chemistry's role in recycling, but clearly I don't have to do that. I'm preaching to the choir here on that score. So what I do want to talk about is how do we make more room for chemistry recycling in the political environments in which we find ourselves. So I've got a bit of a history lesson for you, because we've heard a lot about the efficacy of chemical recycling, and we've heard a lot about the good work that's being done to get validation for the efficacy of what's happening and the safety of what's happening. And I think that's all very important work, but frankly, that's all just table stakes. That is something that must happen for any change to happen. But if we're going to really see governments make room for this kind of innovation, we need to respond to the social and the political and the economic drivers that are happening at any particular point in time. And I want to illustrate that by going through a bit of a history lesson on the blue box in Ontario. And for our American friends, I think the evolution is the same everywhere, but the decades might be different. So I'm just going to walk us through what happened since the 1980s when curbside recycling started in Ontario. The 1980s are when Margaret Atwood published The Handmaid's Tale. It's when Di and Charles got married. It's when the Soviet Union disintegrated and the Berlin Wall came down, just to give you some context. And what was happening in this space was the expansion of curbside recycling throughout the province of Ontario, and the political and social drivers there, the social drivers and the political drivers were embarrassment among Torontonians about convoys of garbage trucks going down to Michigan because we had nowhere to put our garbage. And so that created some social momentum to get into recycling. From an economic perspective, it was when the beverage industry and others were looking at convenience packaging for their customers and wanted to put their packaging in single-use containers. And there was political resistance to that because it didn't mean refilling and recycling. So by getting a curbside recycling program up and running, it facilitated the desire of the consumer to get convenience and for the industry to be able to deliver that convenience while still responding to that embarrassment of trucks going down to Michigan. So things happened then with respect to the blue box, and the way it happened had to do with those political and social pressures that were happening at the time. Then came the 1980s, and for the benefit of our American friends, the 1980s was the emergence of the hip, the iconic Canadian band that anyway, I won't go into the hip. But what else happened in the 90s? Well, that's when liberal democracy seemed to be taking over as the future of the planet going forward. The Soviet Union at that time, or Russia at that time, seemed to be embracing liberal democracy. And what was happening in this space was, in Ontario, the blue box became a very iconic brand. The consumers loved it. They wanted more of it. But the economic realities of collecting, processing, and marketing the materials became much more apparent because every municipality across the province was doing it. It was costing a lot of money. And at the time, the provincial government of the day was taking the money it had been giving to municipalities away from supporting those sorts of things. So it all then moved onto the burden of the local taxpayer. So while you had a brand, Blue Box Recycling, which was iconic as much as the hip in terms of its embracing of the population, you had a very significant economic pressure on the systems that were built to do it. So what did that lead to? Well, that led to the aughts, and the iconic moment from the aughts was, of course, 9/11, which a current play is not celebrating, but reflecting back on. And I don't have to remind you too much about what was happening in the aughts, but what was happening in this space was the creation of the stewardship models that we lived with through the aughts. And that meant not fundamentally changing the way we were collecting and recycling materials, but instead simply trying to find more pockets from which to get money to pay for it to happen. And so stewardship and Blue Box put the burden on the packaging goods sector and the retail sector to give money to municipalities to continue to run the system that was happening at the time. And again, there were strong political and economic and social motives behind why that happened at that time. And it had to do with the brand of Blue Box still being extremely strong. The desire of industry who were paying for it to pay as little as possible for it, but not to disrupt what was happening out there too much. Some of the economic drivers led to a lot of expansion and innovation in terms of mechanical recycling. The engineers really came to their fore in the aughts with optical sorting technologies and all kinds of things in an effort to get the cost down. We also had, if you don't forget, $120 oil. $100 and $120 oil makes a very different economic environment for recycling, particularly recycling of plastics. Because when oil is at $120, the value of the recycled commodities that you could get is much higher. And in fact, in the aughts, leaving out the collection side of the equation, companies were making money out of the processing process because it cost them less to sort and prepare materials for market than they were getting in terms of materials. That certainly doesn't exist that way today. What also emerged at this time politically, which I think is perhaps the most relevant thing for us today, is this concept of highest value use. And for governments and for NGOs and for people in the environmental industry, highest value use meant like for like. And that means if you're recycling a bottle, you have to make a new bottle out of it. If you're recycling a tire, you got to make a new tire out of it. How you recycle a computer and make a new computer out of it, I don't know, but that was the gist of what represented highest value use at the time. And it was driven by a number of social and economic factors again, because the government was observing glass bottles going through the Blue Box, getting ground up into powders that were too contaminated to do anything else with other than use it as aggregate in roadbeds. So the idea was, well, if we can force them to turn a glass bottle into a glass bottle, then that will force higher value use out of the material. The problem with that way of looking things is you instantly turn your recyclable, the markets for your recyclable materials into the narrowest possible market you can possibly conceive of. A bottle has to be a bottle. You don't have to have a PhD in economics to know that if you turn the potential market for a material into one, that the price of it is going to go down, and it's not going to become economical anymore. So, what's happened in the 2010s? Again, for our American friends, there's nothing more important than happened in 2010 than the golden goal, and to watch the puck go behind a goalie with a USA on his chest from that number 87. So, enough said. Anyway, in the aughts, everything changed in terms of how governments and the socioeconomic and political pressures that were on the recycling system. And the response was to shift the thinking is to shift the burden onto the polluter much more directly and expose the polluter to more options for how they deal with their pollution, much more of a cap and trade kind of mindset for it, and that's the new legislation that's been built in Ontario. But the other pressure that's happened, of course, here is we no longer certainly have $100 oil, and the value of the commodities through the mechanical recycling systems is plummeting. And so the pressure now is to figure out other ways to deal with it. And some of the companies here in Ontario, pioneers in the most effective mechanical sorting technologies that there are, but it still means that one material needs to go to that same material. So we're really at a crossroads today. We can either deal with the economic and social pressures that are out there by reducing the amount of materials we capture for recycling, trying to make it reasonably economic viable by putting more burden on the consumer to clean the material more, to sort it better, whatever. Or we can look forward to a new world that is exposed to innovation and that brings some of the technologies that we've been talking about today to the forefront. But in order to do that, we need to encourage governments to make space for it. And today, the Ontario government at least is still in the mindset that highest value use means turning a bottle into a bottle. So how are we going to get them to think differently and think in terms of innovation and think in terms that will allow the sorts of technologies we've seen today to be welcomed as opposed to discouraged? And as I said at the beginning, the table stakes are efficacy and safety. But we've got to, and I'm not going to pretend to tell you what the answers to the social and political pressures are today, but those are the things that we need to figure out, and those are the things that we need to respond to if we're going to get governments to change the regulations to expose money-making opportunities to these new technologies. So I'm going to skip this slide because everybody's been told about how good chemical recycling is now. And we've heard some of these companies we've talked about today. But some of them are following a process, and they're being successful in Ontario, and they're following a process that really isn't recognized by the newest recycling legislation or producer responsibility legislation in Ontario. But these are companies that have the potential and are going to be making money. And I'm going to give you a little bit of detail on, just because it happens to be the one I know best, is Char Technologies. Char Technologies' first product is a product called Sulfachar. Sulfachar is manufactured from the digestate from, well, one of the input materials that can be used to make Sulfachar is digestate from an anaerobic digester. And what does that Sulfachar product do? Well, that Sulfachar product is specific to H2S. Now, H2S, typically from an anaerobic digester or a landfill or any other source of renewable gas, tends to be extremely sour with H2S. So if you're going to use that renewable natural gas in the grid, you got to get the H2S out of it. So ironically, you're using the output material from an anaerobic digester to make a material that can then remove the H2S from the gas generated in that anaerobic digester. Now, that's not turning a banana peel into a banana peel, but it's certainly innovation that enables us to deploy sour gas in ways that have been uneconomical to do in the past, which is why most of it gets flared off today. The second product from the newest product from Char Technologies is a product called CleanFire. Now, CleanFire is also manufactured from digestate and other organic materials, and it's made into a biocoal, a CO2 neutral biocoal that meets the specifications of the steel industry. Now, I'm not a chemist or an engineer or any of that stuff. What I do know is that you can't make steel without coal. And coal, as we all know, is the highest source of greenhouse gas emissions among the fuels. It also produces a lot of other particulates and things like that. So if you can replace coal with something that's carbon neutral, then you're onto a good thing. And the latest product from Char Technologies, which will be tested at Dofasco here in Ontario, can meet those standards and will be able to generate steel from a neutral coal. And this one product alone has the potential to reduce Canada's total GHG emissions by 1%. And that's a product made from the output of an anaerobic digester. And I highlight these two because I know about them. I'm on the board and I'm an investor. But I highlight them to emphasize my point that there are a variety of social and political drivers of government decision making. And this technology exists because of its inventor's understanding of chemistry. And it's solving multiple problems for our environment. And as long as government regulation is so narrow as to predefine what is a high-value use, the conditions for products like this to be a success are inhibited. These products are going to be a success despite the regulations. But how many more things out there? We've talked about chemistry-related technological innovation that has failed. Yeah, some of it failed because it didn't work. Some of it failed because the economics never would have worked. But some of them failed, frankly, because the regulatory conditions didn't exist for them to succeed. And if we're going to persuade governments to make decisions and put in regulations in place that respond to what we need to get our technology off the ground and into market and succeed, we're going to have to address them in terms that they understand, and that means how does the technology affect the social, economic, political, and job trends that they are facing in putting forward in managing provinces and countries and municipalities. I don't know the answer to how we're going to do that, but we need to start thinking about our government relations in those terms as opposed to the table stakes of this is okay because, or don't worry about this, yeah but. We've got to say this is actually a solution to your innovation problem, to your scale-up problem, to your employment problem, to your high-value job component, to your knowledge economy component. Bring all of those arguments to the government, and those are the arguments they understand. They understand the chemistry less than I do. So let's stop talking about the chemistry and talk about the social and political drivers that are getting in the way of the decisions we want them to make. Thank you.
What is the number one thing you've got to do more of what you're doing now at your organizations? The number one thing.
I could give the normal answer, more access to capital, faster to market, all those sorts of things. But I think it relates to what I was saying. We can do a better job of helping governments see that they don't have the answers and that nobody has the answer that's going to solve the problem 10 years from now. But they do need to recognize that that answer will come because they create the conditions for the answer to emerge. And they haven't quite got there yet.
Sandy.
I guess I would say that we can continue to support the ecosystems that are out there. Our role is really about connectivity between different groups and working with the various stakeholders. We get an opportunity where we sit to see a lot of different technologies, and we get to see pieces from here and there. And by working through our connectivity and saying, you should talk to you, and working within these systems, we can help these companies accelerate to commercialization faster, which is really what we need to do, is help them to get there faster and help them to scale faster.
Awesome. Awesome. All right here in Ontario. A question. Joe.
Okay, just a quick one. Do governments need to recognize resource recovery does cost money? And should there be better credits, input credits, all those kinds of things? Yes, no? Do you have any solutions on that?
I think that, yes, they do. They need to be neutral in their regulations about which technologies are going to emerge and which solutions are going to emerge. But I think I think the problem isn't what we ask governments to do. I think the problem is with us and helping governments recognize that what we want them to do responds to their social, political, and economic drivers. And if we do a better job of that, we'll get the regulations we need.
I guess I would say that it's the role of government to help us change and force these materials to be collected. And what will happen is, in the short term, that will drive the prices down, and there will be incentives built into that so we can innovate. Over time, we will discover ways to get these products to higher value And at that point in time, we'll be able to afford a higher price for these materials, and maybe over time, we won't be having to have tipping fees for them. We're a long way away from that, but I think you have to let the economics work, or let the economy work on that, and let the market drivers drive that. But I think the first piece is government's role of changing behavior so those materials are recovered and pushed into reuse.
And I'd like to just add one more, and it goes back to what Michael said earlier. The answer will come in pricing waste. Most people who understand economic drivers understand that pricing carbon, however you might price it, there are ways that are better than others, but if we're going to deal with the climate, we need to price carbon. If we're going to deal with waste, we need to price waste. And as long as you can put it in a hole for $25 a ton, we're going to be struggling to see these more innovative solutions come forward.
Agreed.
Awesome. Thank you. Center floor.
Connie again from Western
Connie.
University. Thank you. I really have a really general question. It's kind of related to what Joe asked before. So my question is, over these 2-day conference, we heard about a lot of really, really good ideas. Have they been made to the governmental level? Like, have the governments reviewed them? Like, check them. What's the feasibility of those great ideas? And if so, why are we not implementing them yet? Like, what are the reasons that government gave us saying that, no, we're not going to do this? I'm curious, what are the reasons?
I think they don't understand them, and I think it's because we've been communicating to them in the ways that we understand, not in the ways that they understand. So I think we need to bring some more salesmen into our sphere, and people who know how to sell ideas, and people who know how to understand the needs of the customer, and explain the benefits in terms of those customers' needs. In this case, the customer is the government. And their needs are, as I've said, economic, social, and political. So we need a way of translating the value that we're creating to show them that if they let us create this value, that it will respond to their social, political, and economic needs. And I don't think we've done that. And I don't think we're ever going to get them to understand the technological innovations we heard about over the past couple of days. They're all very technical, and they respond to a specific economic need, but it's far too specific for particularly the kinds of governments that are emerging today that speak in terms of slogans. And they understand the slogans. So, we've, as I said in my presentation, I thought the 1990s were the final triumph of liberal democracy and evidence, but that only lasted 15 years. So now we're back to slogans. So we got to find a way of responding to those slogans in a way that will get them to act.
So my comment to this is, I think it's unfair to expect them to understand. They're smart people, and this is nothing derogatory at all towards our public officials. They're very smart people, but everybody has a capability to handle certain amounts of information, and we all have various levels of training and various expertise. You hear often around here people in the last year or so, I'm a business guy, I don't understand the technology stuff. First to admit that. I think when you're dealing with the government people, they're very busy. I can't believe the stuff that they have to handle and the stuff that gets thrown at them very quickly on short notice that they have to respond to. They work hard. They can gather what they can. I think it's up to us to help them to understand the basics they need to, and then let them focus on putting in good, solid policy that allows us to bring those answers.
Can
Thank
I
you.
say,
Oh.
sorry.
No, please.
Can I say that because the traditional way doesn't really hit them as like a big problem, so they are afraid to step out of their comfort zone. Can I take it as that? Because innovation does involve risk, and if they are comfortable with the current approaches, can I say that they are not comfortable stepping out of their comfort zone and just continue with the tradition way of doing things?
I would say in the civil service side, I don't necessarily agree with that. I think there are people on the civil side of this who are trying to be risk takers. They deal with some realities from time to time, which mean you have to be a little more cautious. That's no different than being in the public sector. I know times when I was in my career, I was able to be more aggressive and more risk-taking on things, and other times you ducked your head. So it's no different there. I think the political side has a more difficult challenge because they're judged minimum every 4 years.
We have been talking about waste is a resource. And I just want to have some suggestion about how to build a sustainable business. Chicken feathers, today I pay to dispose of them. As soon as you start making money, I'm going to charge you. How do we make a sustainable, what's the best way to make a business where we can make it sustainable?
I would say partnerships. I would use the example of the Comet biorefining. They have partnered with the Cellulosic Sugar Producers Cooperative, which are the farmers who have the biomass. They're co-investing in the plant. They're working together to optimize both sides, whether it be aggregation or conversion. And if there's trade-offs in there, they collectively decide which one they do, that they maximize the return to each. And so it's those partnerships that I think create those greatest opportunities because they de-risk the business.
I like your answer because this is what I believe as well.
Well, I think, and there's even a simpler form of that, and that's what I like to say, help the bear find the rabbit. So the Char Technologies Clean Fire, when that takes off, we're going to need every source of organic material that we can find. And I don't know technically if we can turn chicken feathers into clean fire, but boy, if we can, we're going to be knocking on your door saying, how much of this stuff can you sell more chickens so you can give us more feathers? So it's finding ways of turning material into other material that the marketplace really wants. The more of those we discover, then the more demand there will be, and we can get your feathers from a negative price to less of a negative price to a zero price, and maybe one day we'll be buying it from you.
Excellent. Thank you, and a big round of applause for our panelists.